So, both non-homogeneous shading and accumulation subject can bring about thermal imbalance to the panel structures, which will cause the panel will get damaged and result in a huge efficiency in solar power generation. As stated in the problem statement, so I have come with a proper solar panel monitoring system for the solar panel user, which can be accessed through the mobile and to present a more affordable options for the solar panel monitoring by presenting the IOT-Enabled photovoltaic monitoring device to assist the user. I also introduced a proper dust detection device to detect dust and monitor other parameters throughout the period remotely. To tackle on the segment on our solution and why it's better, I've presented a wireless monitoring including the dust detection method and proposed stable wireless connection method as I use ESP32. I also have designed a monitoring system that can be monitored remotely as I use Adafruit and Mqtt, which will present the data in real-time display in a user-friendly way. So, there are three main points for my proposed solution. First, it is a holistic sensor-assisted monitoring system. Second, is a working battery charging module. And last but not least, it is a systematic method for notifying upon dust detection.
What is this system basically does? It allows us to monitor the solar panel using our smartphone. The system is connected to Wi-Fi and sends all the data from the solar panel sensors through Arduino and directly to the database. While the database can be accessed with two platforms, which is the first one for Android application, it is called as Mqtt Dashboard, and the website called io.adafruit. We can also observe all the data and all the parameters in the platform at the TTGO display on the donut board. We can monitor our solar panel by observing the PV cell temperature like intensity, voltage, and the presence of the dust. So, there are 4 sensors used to monitor all the parameters. So, let us see the hardware and the component used. Now, I will do testing on the sensor used. On the left part is the real-time update on the smartphone apps. The value increased as I provided heat from my hand. The light intensity value decreased as I handheld the LDR sensor to block all the light from passing through the LDR sensor. So now, I will demonstrate the IoT-enabled photovoltaic monitoring system with a clean solar panel. The Adafruit platform, it shows the data reading that sent by the ESP32 by its respective sensor. As we can see here, the value for the first column is the voltage sensor. It displays the value ranging from 5.3, so the value of the voltage for a clean panel is higher than the dirty panel. Second column is LDR sensor. The value displayed within less than 4000. And the third column is display the temperature sensor LM35. It displays the value of the temperature that detected by the sensor. And the last one is dust sensor. Since the density of the particle that detect is below than 0.1, so it considered that the dust is not detected on the surface of the solar panel. So all the sensors here are showing the reading in a real time. Okay, this is gonna be for the part 2 experiment, which I will experiment between the clean panels and the dusty panel. So, in order to examine the dusty panel, I just put a little flour above the solar panel. It is for a mimic of a dusty solar panel conditions, or when the dust accumulations already placed at the above of solar panel when the solar panel is not clean in a time of period. The dashboard of the Adafruit platform, it shows the same parameters. So if you want to do a comparison, so the voltage sensor is showing a value of 4. So it tells us that the T solar panel, the value of the voltage is lower than the clean one. For the second LDR sensor, the value is lower than the clean solar panel. So since the dust is blocked the LDR. The third sensor is temperature sensor. We can detect here that the temperature is increased a little bit compared to the clean solar panel, since like when the dust accumulation will increase the temperatures of the PV panel. And the last one is dust sensor, since the particles detected by the optical sharp dust sensor, when the dust density is higher than 0.1, so the dust will be detected.